Hi, welcome to another exciting Unity tutorial with me, Romy Fauzi. In this video, I'm going to show you how to create a 2D aiming mechanic using the Unity 2D rigging and also Playmaker. And this is what are we going to create here. So here, as you can see, we can aim the rifle using mouse and we can go to the other direction here. We can aim to the other direction and it will flip the character automatically. And we can also move the character. If I move, you see that it has a walking motion. But if I move backward, whenever we are facing to a certain direction, it will play the backward walking animation. So this will also work to the other side, as you can see here. And this is what are we going to create in this video.
But before we jump into the tutorials, if you want to learn how to create a game from scratch to a complete game, check out my online Unity courses. I've published a couple of courses covering best practices in game development with topics ranging from programming to visual tuning, desktop to a mobile platform, object-oriented programming, and many other useful tips. With the price of a takeaway, you'll get lifetime access to the course. Link in the description below.
Okay, so now here I've already have a character rig set up, and if you want to know how to create this 2D character rig, you can check the video and I'll put the link in the description. I've already covered a tutorial on how to create this kind of rig and also create the IK. Here, if we expand the soldier game object, you see that we have all of the IK for the right foot, the left foot, the right hand, and the left hand. And I also already created an animation, the idle and walk, and I'm going to create a controller. So let's just create an animator controller and let's just call this soldier. And I'm going to go to the soldier game object here and let's add an animator component. And let's drag the soldier animator controller that we have created to the controller slot here. And let's go to the animator here. And here we are going to create a blend tree movement, but I'm going to do this later. For now, I'm going just to drag the idle clip and the walk clip. And I'm going to show you this animation here. So if I go to the scene view here and select the soldier game object, let's just minimize the sprite skin here so we don't see the bones. And if I go to the animation window here, you see that I have this idle animation. And the idle animations basically just move the pelvis and lock the foot IK position. And for the walk animation, it's basically moving the foot IK in a cycle motion like so. Okay, and I don't do animations on the hand at all because for the hand we want to hold the weapon and we want to create aiming mechanism. Okay, so now we need to create the weapon first. Before creating the weapon, we need to create an empty game object here, and I'm going to call this weapon transform. And let's just put this weapon transform here in the middle, in the tummy area. And let's add the gun art here. I've already have a rifle and I will share this project in the description. So let's just drag this rifle sprite here and I'm going to put this as a child of the weapon transform. And here I'm going to put the weapon around this position. Okay, so now we have this weapon here. We can drag the right hand IK to be around this position here and we can rotate this. And as you can see here, the weapon is drawn in front of the hand. So we need to fix this, but I'm going to show you how to fix this in a moment. Let's just adjust the left hand IK and I'm going to put the left hand IK around this position here. And then I'm going to set both of these right hand and left hand IK to be the child of the rifle. So let's just drag both of this game object here and I'm going to drag this as a child of the rifle. So now if we rotate the weapon transform, you see the hand will follow the rifle position like so. And if it's too narrow to the body here, as you can see the rifle, we can adjust the rifle position by moving the rifle here and we can just put it around this position, for example. And now if we rotate the weapon transform here, we will have a much better motion, aiming motion, or we can just move the rifle to be on the same y-axis with the parent, which is the weapon transform here, and then move the weapon transform slightly above here, like so. So we can now rotate this and it will have a better aiming. And basically with this parent game object, this anti-game object, we want to rotate this depending on the mouse position. So this transform will follow the, or will calculate the degrees pointing to the mouse position. So we have this aim mechanism working. So let's just reset the rotation value here, and now we need to cover this art here. So in order to do that, I've already created a circle sprite and a square sprite, and you can just create a sprite using the create menu under sprite, and we can create basic shape like square and circle. So we need circle and square here, and now I'm going to expand the pelvis here, and let's expand the right arm. So first we need to create a square on the right arm here, and let's just move this to be this position here. And now let's set the order in layer under the sprite renderer to be bigger than 0, make it 1 here. And now we need to adjust the sprite size, so let's just adjust the sprite size here and make it like so. I'm going to make sure that it covers the hand here, and I'm going to add a circle to be the child of this square. And I'm going to set the sprite layer or order in layer also to 1 here, and make sure that the scale is smaller. By holding shift you can scale it proportionally, and I'm going to put this around this joint here. Okay, and let's duplicate the square, and I'm going to move this to above here. So we create some sort of a sprite that covers the hand here, and with this 3 sprite selected, we can use the color picker and we can pick the hand color here, so it will blend nicely with the sprite art. And we need to make the same object for the forearm and the hand here. So let's just duplicate this game object here. I'm going to make this the child of the forearm game object, and let's just minimize this, and I'm going to fast forward the video. Yeah, I think this should be okay. And now the next one that we want to create is the cover for the hand. So I'm going to drag a square to be the child of the right hand game object here, set the order in layer to 1, and I'm going to make sure that it covers this part here. Okay, I guess this should do, and let's just pick the skin color here. It's not perfect, but I think we can get away with it from the distance. And now we can just minimize all of this bones game object. And if we select the weapon transform, we can just rotate this and the rifle will be drawn behind the hand. So now we have this working. Let's create an FSM to create an aim mechanic. So I'm going to disable the preview of our animation, and let's open the Playmaker window here. And let's create a new FSM. So this will be the aim. So let's just rename the FSM aim. And I'm going to create the first state, and let's just call this facing right. And we want to create mechanics where the weapon transform will follow the mouse position, and it will look at that mouse position to rotate the rifle. So first we need to get the mouse X position and also the Y mouse position. So let's just grab the get mouse Y. We need to store this to a float variable. So let's just create a new float variable, mouse X, and we want to disable the normalize. And let's create a new variable for the mouse Y. And now we want to build this to a vector. So let's create a new set vector 3 XYZ action, and this will create a new vector. And let's just create a new vector3 variable. Let's just call this mouse screen. And for the X and Y value, we want to pass the mouse X and the mouse Y. And check every frame. And let's just minimize all of this action here. And now we need to convert the mouse screen into mouse world, because this coordinate is on the screen coordinate, which is the UI coordinate. So we need the world coordinates, and we can use the screen to world point here. So here I'm going to use the mouse screen and going to convert this to the world vector. So let's just create a new variable and let's just call this mouse world. And for the screen Z value, we can just set this to 0, I think, depending on the camera position. Oh, it's -10, so let's just give it a try. Let's set the, oh sorry, I add the aim on the wrong game object. So I'm going to copy this FSM component here and then select the soldier, and I'm going to paste this as a new component here, and we can just delete the one that on the weapon transform. So let's just remove the component here, go back to the soldier. Now we have the FSM in this game object. Let's just select the screen Z to -10 and enable the every frame. So now we have the mouse world position. Now we need to make sure that the weapon transform follow the mouse world position. So let's just add the look, I think it's look 2D, smooth look at 2D, and we can use this action here. And for the game object that we want to look around, it's the weapon transform. So let's just specify game object and then drag the weapon transform. And for the target object, I'm going to disable target object, but we want to use the target position, and let's just use the mouse world. And for the rotation, we want to keep the offset to 0 for now. And now if we save the scene, let's give it a try. Okay, now as you can see, we have a very nice aiming mechanism. But the problem is here, if we flip the mouse to the other side, it will flip the hand and the character stay facing that direction. So we need to fix this. Okay, now let's just minimize the smooth look at here, and let's just duplicate this state and then paste this state here. And I'm going to call this facing left. And on the facing right here, let's just compare the X position of the mouse cursor world. So now we need to store the X position for the mouse world. And here, luckily under the screen to world point, we can save the separate XYZ component world here. So we can just create a new variable, and let's just call this mouse X world. And we need to get the player position, the X position of the player. So let's just use the get position action here and store the X component to a new variable, and let's just call this player X position and check every frame. And now we can compare this value here by comparing using the float compare. And basically now we are facing right, so we want to check if the mouse world or mouse X world is, sorry, is, where is it? It just keep opening the other action, I don't know why. If the mouse X world is smaller than the player X position, it means that we have gone to the left side of the player. So we can just check if less than this player X position, then we want to go to the other state here. So let's just create a new event from the less than, and then we can just call this turn left and make sure every frame is checked. And we need to add that transition turn left, and let's just connect this to the facing left state here. And for the facing left state, we need to copy this get position action here and the float compare. So let's just copy this here and then paste it on the facing left state. Okay, so here for the get position, we already getting the player X position because we copy from the facing right, and we already did the comparison here. But instead of turning left, we want to create a new event, and let's just call this turn right, and let's add the turn right transition here so we can go back to the facing right state. But here under the, I think it's, yeah, in the screen to world point, we need to save the store world X on the facing left because we haven't done that. So I'm going to save this to the mouse X world. And now we have this. And we need to adjust the smooth look at 2D offset to 180 degrees because we are facing a different way. We are facing that way. So the default value should be in this direction. And now we have set this, we need to create a mechanics where we are going to flip the game object. So in order to do that, let's just create a new FSM here. And for the second FSM, we can just call this direction. And by default here, we want to set the first state to facing right also. And whenever we are facing right or we enter the state, we want to set the scale. And for the X scale, we want to set this to 1. Because as you can see, whenever the game object is facing to the right, we have the scale of 1, 1, 1 on all of 3 axes. So we want to make sure that this is set to 1 and the rest is also 1. And we don't need to check the every frame here. And here we want to add the in switch action. And we want to create a new variable for the in switch. And let's just call this direction. And we want to check for 1 switches only. And if the integer is -1, then we want to flip to the other side. And this needs to be every frame. So let's just enable this here. And let's duplicate the state here. And let's just call this facing left. And for the facing left, for the set scale action, let's set the X value to -1. And here we want to wait whenever the direction value becomes 1, then we want to switch state here. So here we can just create a new event and let's just call this turn right. And add that transition, turn right, and connect this to the first state. And for the first state, we can just create a new event called turn left. And we can add a transition turn left and then connect this here. Okay, now we have set up the direction, but this won't work yet because we need to set up the direction value, or we need to give some value here. And by default, the direction is set to 0. So I'm going to change this to 1. So it's facing to the right by default. And let's go back to the aim mechanics here. And whenever we are facing right, we want to set an FSM integer value here. And I'm going to put this above the float compare, or I can just move this to the top. So it will be the first action. And we can just use owner and pick the direction FSM, and the variable name should be direction that we want to fill some value to it, and set its value to 1 because we are currently facing right. And here I'm going to copy this action by right clicking and click copy selected action, and then on the facing left state, let's just paste the actions before. Yeah, there you go. And here for the value, let's just set this to -1 because whenever we enter the facing left, we want to flip the direction here. So now if we save the scene here, let's give it a try. Now it's facing right. But if I go the mouse to the left side, oh, there is an error. Let me check. Yeah, there is an issue here. Basically on the facing left state here, under the float compare, I need to change this to greater than. So whenever it's greater than, we want to turn right, and we want to leave the less than to empty. Because when we are facing the left side here, the mouse should be on the left side of the player. So whenever the mouse goes to the right, it means that the mouse X world will be greater than the player X position. Then we want to turn right. And before it causes an infinite loop. So I'm going to save this scene again and let's give it another try. Okay, now we can aim on the right side. Let's go to the left side, and there you go. We can aim on the right left side. And as soon we flip side, you see the characters flip. So now we have this working nicely. We need to set up the animations next. And now in order to create the animation, we need to modify the animator setting here. So let's just delete the idle and the default state here. And I'm going to create a new blend tree here. So let's just create state and then pick the from new blend tree. And inside this blend tree, we have this parameter by default created by the blend tree. So let's just change this blend to speed. And if we select the blend tree here, let's add a motion. I'm going to create 3 different motion here. And the first one, I'm going to pick the walk animation that I've created and I've shown you before. And then for the middle one or the second one, let's just select the idle. And the third one will be also the walk motion. So we have 2 walk motion. And I'm going to enable the automate threshold so I can set up the threshold manually. And for the first threshold, I'm going to set this to -1. And for idle, I'm going to set this to 0. And for the walk, I'm going to set this to 1. And for the first walk, we want to set the speed of the animation to -1. So it will play the animations backward. So it will create a walking animations that is walking backward. And now we have set this up here. Let's go to the scene here and select the soldier game object. And we need to create a couple of components here. So let's just add a capsule collider. And we are going to adjust the capsule collider size and adjustment. And I'm going to add a rigid body 2D. And for the rigid body 2D, we need to constrain the Z rotation here. Okay. And now let's just go to the animations, and I'm going to pick the idle animations because there is a slight offset as you can see here. So I'm going to lock this here, and I'm going to adjust the collider based on the idle animation. So let's just click this button here, edit collider, and let's just adjust the size of the collider so it fits the character body. And for the leg here or the foot here, I'm going to align this lower part of the collider to be aligned with the foot of the character. Okay, so disable the edit collider button. Now we have this set up. Let's just unlock the animation window and disable the preview. And now we have these 2 components. We need to create a new FSM for moving around, and this will be a very simple FSM. So let's just create a new FSM and let's just call this movement. And as for movement, usually we need to use the get axis. So let's just get axis here. And let's just type horizontal, and this will return a value -1 to 1 depending on the left or right arrow that the user are pressing. And we can store this value to a new variable. So let's just call this input speed. For the multiplier, I'm going to create a new variable, and let's just call this walk speed, and make sure every frame is checked. And then after we get an input, we want to set the velocity of the player, so we can use the set velocity 2D. And I'm not going to use a vector, but instead I'm going to pass the input speed to the X speed here, and make sure every frame is checked. And now we have this. Now it's working, we can move around, but we need to synchronize the animations. And as you can see, we have created blend tree here, and we have 2 walking motion. This is walking backward and this is walking forward. So now we need to create a calculation where the animator will know whenever we are facing left or right. Then if we are moving to that direction, we should walk forward. But if we are moving away from the direction we are facing at, then it should walk backward. So in order to do that, it's quite easy actually. We can always get the scale of the X component of the player, because whenever we are facing right, then the scale X will be 1. And if we are facing to the left side, the scale X will be -1. So in order to get the scale, we can use the get scale action. And then we can save the X scale to a new variable, and let's just call this scale X, and check every frame. And now we want to create a new float variable. So I'm going to use a float value, set float value here. And I'm going to create a new variable called direction relative speed. And here for the set value, I'm going to set the new variable value to the input speed here. But we want to clamp the value to be -1 to 1. So let's just add I'm going to minimize all of this action. I don't know why, but Playmaker keeps expanding whenever I add a new action or I create a new variable. So let's just use a float clamp here, and we want to clamp the value of the direction relative speed. As you can see, it keeps expanding. I don't know why. It's very annoying. I'm going to maximize the window so we can see it better. And let's set the minimum value to -1 here and the maximum value to 1. And I'm going to enable the every frame here. And then I'm going to multiply the float value with the scale X of the character. So let's just use the float multiply, and we can just pick the direction relative speed variable and multiply this by the scale X. That means that whenever we are facing to the right, then the value will be unchanged or will be kept as the original value. But if the player is facing to the left, then the value will be inverted. And with this direction relative speed value, we can assign this value to the speed parameter on the animator. So if I minimize this window here, go to the animator, we can pass the direction relative speed to the speed value here. And this will trigger the blend tree to work nicely with the FSMs that we have set up, and it will play the animation accordingly. I don't know why the Playmaker window is error now, so I'm going to go to open the window again here. And now let's go to the movement FSM. Now we need to trigger the speed, or we need to use the set animator float. So let's just use the set animator float action and use the owner, because as you can see, the animator is on the same game object as our FSM, so we don't need to change that. And we can pick the speed parameter here, and for the value we can pass the direction relative speed. And let's check every frame here, and now let's save the scene. Another thing that I need to change is the walk speed here is 0 by default, so I'm going to change this to 4. And here I forgot to check the every frame for the set float value, so I'm going to do that. And also this one here, the float multiply, I seem to forget to check the every frame, so let's just make sure it's checked. And for the float clamp, let's take a look. Okay, it's checked. Okay, let's save the scene here, and now let's give it a try. And now as you can see, if we move around, it plays the walk animation, and if I go back, it plays the animations backward. So it will play the motions depending on the direction and depending on the player facing or looking at, where the player is looking at. And if we go to the other side here, you see it plays the correct motion. We can walk backwards and we can move forwards. Okay, so yeah, that is basically how we create a 2D aiming mechanic using the Unity rigging system, and it will synchronize the animations depending on the direction the player is facing to. So I hope you like this video, and if you like it, hit that like button and don't forget to subscribe. I hope this video is useful. Thanks a lot for watching, and I'll see you on next video.